Recording. What was your question?
What do you think COQ10 means?
That is coenzyme Q10. You're drinking a workout supplement drink. So we'll talk about that after I finish recording. Unless America wants to know what coenzyme Q10 can do for you. Okay. Okay, so we are going to start with properties of chords today. Sorry for the All right, so we'll go ahead and start with moving the orange points to adjust the measures of the arcs and the chords. So if you take a look here and move them around. Where is my mouse? Come on, mouse. It's frozen, just like Dana's computer. Okay. We're going to try to make the chords equal. Someone was able to make them equal in my last class, but I had trouble getting them exactly the same. Chords C, D, and E, F. Let's do it. All right. Oh, there we go. Okay, so you notice when you have a chord, two chords inside a circle that are the same length, the measure of their arcs are also the same. And that's what they're trying to get at here. What do you notice about the lengths of the arcs when the lengths of the chords are equal? We can just say they are equal. We're going to take all these properties that we're learning here and we are going to apply them in a practice example in a few slides. Slide number 28, move the points to make the measures of segments DF and CA equal. So here's DF and CA, so I'm going to do my best. I'm just going to try to make this 6.78. Oop, I did it. And what you will notice, if you can make them equal, is that they are the same distance away from the center. So what do you notice about segments BG and GE when the segments DF and CA are equal? Just say they are equal. Technically, since they're asking, the way they're asking the question, what do you notice about the segments? Segments are congruent. The measures of the segments or the lengths of the segments are what are equal. So we should probably say they are congruent. It's all in how they word the question. Slide 29. Move the points to make the measures of angle ABD and CBD 90. So where's ABD? Angle ABD is currently 53 degrees and CBD is 127. We need to make them each 90 somehow. I noticed that this software is slightly off. Sometimes. So here's an example of how they're off a little bit. These segments should be the same length, and my computer, my software is saying 2.57, 2.55. What's happening with yours when you make them equal? Are they equal or close to equal like mine? Equal? Okay, excellent. They should be. Let me see if I can move this other line to get them the same. It doesn't really matter. We understand, get the point. There we go. They're still slightly off. What do you notice about the measures of the segments AB and BC? Now this question is worded slightly differently. It's asking about the measures of the segments. Measures of segments are numbers and those are equal. So we can say they are equal. We are going to take this information and we're going to now apply it. This is an example of what an SOL problem might look like. So it looks like it appears to be a circle problem when you first look at the problem. But let's take the information and read it and put it on the diagram if necessary. The radius of the circle A is 13. So the radius goes from the center all the way down to the circle. This is not the radius right here. Where would be a useful place to draw the radius? If we drew the radius to either B or C, and I will go ahead and just draw it to B. They told us that the length of the radius is 13. And we just learned that if we cut a chord with a perpendicular segment, it bisects it. So if this chord is 24 units, then each of these segments will be 12. So I'm going to go ahead and write those in. Now, let's look at this problem. What information, we just put on this problem, what information can we use to find the length of x? Anyone? I know you guys in your check-in said you were tired today, but it's got to be somebody that's awake enough to figure this out. It is happening, people. What can we use that we have already learned in a previous chapter? I heard somebody say something. Pythagorean theorem. We've got a right triangle here. With the length of two sides given, we can find the third side. We do know C. We have to put 13 in for C, and I have a little room down here. I'm going to scroll down here and use this space to do Pythagorean theorem. Now this is a Pythagorean triple, which means it's one to memorize, and I already know what the answer is just because I have it memorized. But if you don't, 169 equals 144 plus x squared. Subtract the 144 from both sides, and you end up with 25 equals x squared. And then you take the square root of both sides. So you get x is 5. Leave that up for a second. So the original problem looked like a circle problem, and then when we took the information and put it on the diagram and looked a little closer, we realized it's a Pythagorean theorem problem. That happens often. So find x. We found x. Oh, no, it was 5, right? 5. You got it. Booyah. We're on the last slide. Slide 31. Anytime you get one diagram with a bunch of questions asked about that one diagram, always start at the top and go to the bottom, because you usually need the first one in order to do the second one, and etc. The information above to do the problems below. And that's how they have this one set up as well. So let's see if we can take this information they've given us and make sure it's on the diagram. GT is 5, GU is 3. That's on the diagram. They also tell us that DG is equal to GU. So here, DG, this is the measure of DG and the measure of GU are equal. GU is 3, so GD is 3. I'll go ahead and put that on the diagram because it is not there yet. TU. All right, TU is this length right here. It's in a right triangle. We just did this type of problem. It's a right triangle. We know the lengths of two sides. We can use Pythagorean theorem to find the third side. This is actually a 3, 4, 5 triangle. So TU is 4. You can use the Pythagorean theorem to find that, but we know that. Now, since we know that TU is 4, I'm just going to fill in the rest of these lengths here. So CD has to be 4, which also is AD is 4, and RU is also 4. So let me write those in. And those are probably the lengths that are being asked for next. So let's see, CD, yep, 4. Come on now, 4. TR, ooh, TR is the length of this chord right here. And it's been bisected. So 4 plus 4 gives us the length of TR, which is 8. So you have to be careful that you're answering the question that they ask. Same for CA, that's also 8. BD, all right, BD. Last two questions. How are we going to get these answers? So BD is part of this diameter here, BS. Here's the diameter. We are told that the radius is 5, which makes the diameter 10. And each of these lengths are 3. So that's 6. So to make the entire diameter 10, each of these have to be 2. 2 plus 3 plus 3 plus 2. So let me fill those in. So BD is 2, and SU is also 2. Check my work. Got them all right. It's a good thing. Any questions? All right. Thanks for coming out.